So case study on image classification using convolutional neural network. In recent years, image classification has become a vital task to the industries from healthcare to automobile vehicles. One prominent application is in medical imaging, where the patient's scan reports has to be executed. Like we have CT scans, MRI scans, X-rays. These need to be analyzed by doctors for diagnostic purpose. So instead, doctors scan the report. Why not the algorithms? When we give these images as input to the algorithms, that algorithm needs to identify the complications present. So for that, initially we need to train the algorithms using training data set. The training data set should have the normal patient's scan report and then the complex, then abnormal image scans. That also needs to be included. Only then the ML algorithm will learn the images and it will classify normal and abnormal images. So the objective is to develop a convolutional neural network model that could classify chest X-rays into categories such as pneumonia, not affected persons, and another thing is so after the person who is affected has to be diagnosed using the radiologist. Yes, next. So initially we need to collect the data. So the objective is to identify pneumonia affected persons and not affected persons, and they need to be treated. So data has to be collected. Say for an example, in our class we have N50 number. So initially the algorithm has to be trained. So we need to collect data. So we are collecting 5,000 labeled chest X-ray source as a data set. That data is of the public. It will be available in the network. So that data set is divided into 80:10:10. For 80% of the data set will be given as input to the ML algorithm for training, and then the remaining 10 for validation, and then remaining for the testing. Yes. Next. So this is the architecture model, convolutional layers to extract features from the images. Say for an example, the lungs. How the normal lung will be, how the affected lung will be. So it has to collect the features. Affected lung will be like this. So it's the normal thing. So it has to analyze. For that we are having convolutional layers in the model. If I give you a task, you will be creating a project. For that project you will be having a model diagram. That is what we are going to create. We are having a model that the convolutional layers will take care of identifying the features present in the image. Activation function. So here I already told you the rectified linear unit is used to convert the linear function to non-linear thing in the data set for easy classification. So here we are using the rectified linear unit. There are many functions present. Those are mathematical calculations. Then pooling layers. Max pooling was employed to dimensionality while retaining important features. So category, there are many things evolving in the neural network concept. When we learn one by one, each has its own purpose and applications. Here we are in pooling layers, we are employing the max pooling, and then fully connected layers. That is to perform the classification based on the extracted features. So initially we will be giving the input data set. It will have a number of features. We need to reduce the required number of features, and that required features has to be given as input to the model. Then dropout layers implemented to prevent overfitting. So whenever there is a data set, for example, now we are all going and getting our blood checked. So there will be many things. For identifying a person to be anemia or non-anemia, only we need a certain features, not the BP and then the kidney functioning and then the urine test. These things we never needed for identifying a non-anemic person. So for identifying the purpose and the output, we need certain features, and the features which are not necessary are to be taken out. Yes, next. Training process. In the training process, we are using the atom optimizer for efficient training, and then last function we are implementing categorical class entropy for the computation for multi-class classification, and then the model was trained for 50 epochs with the validation loss. So what is 50 epochs? A machine learning model taking time for one complete study of a training dataset and giving this to a robot. Once if it is reading, yes, it is not recollecting something. Twice it is learning, or it could be able to manage. Thrice it is learning, so it is now actually capable of recollecting everything. So this is called 3 epochs. For a machine learning model, to learn a particular training data set, it needs some epoch. 1 epoch is the time taken for a single read of the entire training data set. Likewise, 50 epochs means 50 times it is learning the same training data set in order to classify the coming testing data set. So how many times we will read based upon our this thing. Yes, next. Challenges. So I have already explained you overfitting, underfitting that exists in machine learning. It's a problem. So that and then imbalanced data set and then noise. These are the challenges present to make the data to get better output. So these needs to be measured. Yes, and also they needs to be rectified. Yes. So the solutions for doing those things is data augmentation. Techniques like rotation, flipping, and these things can be applied to increase the efficiency. And then class weighting, it is used to balance the impact of difference during training. And then the transfer learning. Pre-trained models like G16 and some other things were fine-tuned on the data set, improving accuracy and training time. So from this, you need to develop a mini project and you need to incorporate these things in your data set to get the required error-free output. Yes, next. This is the result. So 92% of accuracy was achieved by undergoing this model with the computations, and then effort score is 0.90 and inference time. It is reduced to under 1 second per image, feasible for cleaning reviews. Yes, next. So this is the conclusion, and we have implemented convolutional neural network for chest X-ray image classification. Yes, we have rectified overfitting, and we have addressed much more things that are needed to be addressed. Yes, next. So implication is this case study highlights the potential of neural network transforming healthcare, improving diagnostic accuracy, supporting clinicians with timely information. Yes. you. Thank you. Thank you.